Now let us discuss the solution for the 30th example. See, the function is defined in this manner. Fx is equal to mod x plus 1 when x is less than 0, equal to 0 when x is equal to 0, and mod x minus 1 when x is greater than 0. Question is, for what values of a? For what value or values of a does limit x tends to a fx exists? This is what the question here. See, if you want to understand this given function here, this is what 0 here, x is equal to 0 and x greater than 0 here, and this is x less than 0. When x equal to 0, the function is f of x is equal to 0 here. See, this is what f of x is equal to 0 in this case. When x is greater than 0, function is defined by mod x minus 1 here, mod x minus 1, and when x is less than 0, the function is defined by fx is equal to mod x plus 1 here. So this you keep in your mind, fx is equal to mod x minus 1. When x is greater than 0, when x is less than 0, fx is equal to mod x plus 1 here. Now, function is defined in the neighborhood of 0 here. Neighborhood of 0, less than 0, greater than 0, equal to 0. See here, in the neighborhood of 0, whether the limit exists or not, that I have to confirm first. So for that, let me calculate the left hand limit in the neighborhood of 0, not a here. Left hand limit is equal to limit x tends to 0 minus. I am, instead of x tends to a, what I have taken? 0 I have taken, because the function is defined in the neighborhood of 0. So that's why I would like to check the limit in the neighborhood of 0. So limit x tends to 0 minus fx. This is equal to limit x tends to 0 minus means it is less than 0. When x is less than 0, function is defined as mod x plus 1 here. And then further, x less than 0. Less than 0 means mod x is equal to what you can write next further? Minus x you can write. Limit x tends to 0 minus this mod x is equal to minus x plus 1. So x equal to 0, its value leads to what here? 1 here. So after substituting x equal to 0, that is 0 plus 1 is 0 only here. Now let me calculate the right hand limit. Right hand limit is equal to limit x tends to 0 plus fx. See, this is equal to limit x tends to 0 plus fx value. X greater than 0. X tends to 0 plus means x is greater than 0. When x is greater than 0, how the function is defined? Can you tell me, anybody? When x is greater than 0, how the function is defined? Fx can be replaced by what? Mod x plus 1 or mod x minus 1? Mod x minus 1 here. Okay. So this is equal to limit x tends to 0 plus mod x value when x is greater than 0. When x is greater than 0, mod x value is only x here. So x plus 1 you can write here. Sorry, it is x minus 1. Not plus 1, it is minus here, because mod x minus 1 is there here. So mod x value is x, minus 1 you have to retain as it is. So its answer is minus 1 here. Now observe here, left hand limit value is 1, right hand limit value is minus 1. So LHL is not equal to RHL. Left hand limit is not equal to right hand limit. So from this what we conclude? Limit x tends to 0, fx does not exist. Fx does not exist. So next question, see, for what value of a does limit x tends to a, fx does not exist? When a not equal to that. See, when x is tending to 0, the function is not at all leading to a certain limit here. So it means that a should not be equal to 0. For what value of a does limit x tends to a, fx exists? Therefore, limit x tends to a, fx exists, definitely exists for all a for all a not equal to 0. For all a not equal to 0. That also I would like to, if you conclude this much is the solution here. For your convenience or for your confirmation, let me confirm this one also. A not equal to 0 has two sense. That means a less than 0 as well as a greater than 0. Let me take a less than 0 here. When a is less than 0. A less than 0. In the neighborhood of a less than 0, let me define the left hand limit. Left hand limit is equal to limit x tends to a minus in the neighborhood of a, but it is not equal to 0 in the neighborhood of a. X tends to a minus fx. Okay. Limit x tends to a minus fx. A minus means x is less than a. When x is less than a, better you take in the neighborhood of a, but x tends to 0 itself you take here. See, when x less than x tends to a minus, this is equal to limit x tends to a minus fx here. What to take fx here? See, a is less than 0. See, it means x is less than, a is less than 0. X is tending to a here. X less than a, which is less than 0. It means as a whole what we conclude, x is less than 0. When x is less than 0, see the function is defined as mod x equal to, fx is equal to mod x plus 1. When x is less than 0, see, you don't get confused, you have taken a where? When x is less than 0, in this part anywhere else you take it here. Not exactly equal to 0. ಇಲ್ಲೂ ಚೆಕ್ ಮಾಡಬೇಕು ಮತ್ತು ಇಲ್ಲೂ ಚೆಕ್ ಮಾಡಬೇಕು ಎನಿವೇರ್ ಎಲ್ಸ್. 0 ಬಿಟ್ ಆ ಕಡೆ ಮತ್ತು 0 ಬಿಟ್ ಈ ಕಡೆ. ಸೊ 0 ಬಿಟ್ ಈ ಕಡೆ ತಗೊಂಡ್ರಿ ಅಂತಂದ್ರೆ when x tends to a minus, where that a is there, left side of that 0. When the a is in the left side of 0, function is defined by what? Fx is equal to mod x plus 1 here. So this is what? Mod x plus 1 here. Mod x plus 1. But this is equal to limit x tends to a minus. See, a minus, but that a is taken left side of 0. When it is left side of 0, less than 0. When it is less than 0, mod x value is minus x itself here. So plus 1. Substitute the value here. So this is minus a plus 1 is the value of left hand limit here. Now let me calculate the right hand limit. This right hand limit ille calculation ಮಾಡ್ತೀನಿ ನೋಡಿ. Now observe here. Right hand limit is equal to limit x tends to what we can take here? A plus we can take. A plus fx. Limit x tends to a plus. Where it is? Again it is less than 0. This condition is a is less than 0. 0 ಈ ಕಡೆನೇ ಇದೆ, left side ಇದೆ. It is definitely left side. So again the function is defined by mod x plus 1 itself here. Mod x plus 1. So x tends to a plus, x tends to a plus mod x. Mod x is equal to what? Even though it tends to a plus, means x is greater than a. ಹೌದು ನೋಡಿ, greater than a, but it is in the neighborhood of a, but as a whole less than 0. When x is less than 0, fx is defined by mod x plus 1. So you need to take mod x plus 1. So mod x value is when x is less than 0, mod x value is minus x here. So plus 1. So definitely again minus a plus 1 you can write here. See what we can confirm, right hand limit is equal to left hand limit. See from above, RHL is equal to LHL, or you may write LHL is equal to RHL. Left hand limit is equal to right hand limit, and both are tallying with minus a plus 1. Therefore limit x tends to a, therefore here only I have to conclude this. Therefore limit x tends to a fx exists when see the condition, when a is less than 0. When a is less than 0. So ಈ ಕೇಸಿಗೆ ನಾವು ಕನ್ಫರ್ಮ್ ಮಾಡಿದ್ವಿ ನಾವು a ನಾಟ್ ಈಕ್ವಲ್ ಟು 0 ಮೀನ್ಸ್ a ಗ್ರೇಟರ್ ದೆನ್ 0. ಅವಾಗಲೂ ಕೂಡ ಟ್ಯಾಲಿ ಆಗಿರ್ತದೆ. ಸೊ ನೆಕ್ಸ್ಟ್ ಒನ್ ಏನು ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡೋದು ಅವಶ್ಯಕತೆ ಇಲ್ಲ, ಆದರೂ ನಿಮ್ಮ ಕನ್ಫರ್ಮೇಷನ್ ಮಾಡಿ ಹೇಳ್ತೀನಿ ನೋಡಿ. ವೆನ್ a is greater than 0. This is not necessary, but I would like to conclude this. When a is greater than 0. left hand limit is equal to, you see here limit extends to a minus fx, a minus fx. This is equal to limit x tends to a minus. Here you have taken a minus. Please concentrate here. That a is taken here. 0 the akade tagondidini. Ille draw ಮಾಡಿ ಹೇಳ್ತೀನಿ ನೋಡಿ. See ಇದನ್ನ ಏನು ತಗೊಂಡಿದ್ದೀವಿ? This is 0. Here you have taken a is taken here. A is greater than 0. 0 the ಆಚೆ ಇದೆ. So in the neighborhood of this point, in the neighborhood of this a, I would like to check the limit here. So fx is equal to what for this? For this fx is equal to either for left hand limit and right hand limit. Fx value becomes same here. What's that? Fx here? Fx is equal to mod x minus 1. Mod x minus 1. This one you need to use in this situation for both left hand limit as well as for right hand limit here. X tends to a minus. Fx value is mod x minus 1. So the answer is limit x tends to a minus. A minus. See, it is a is right side. It means x is greater than 0 here. X is greater than 0. When it is greater than 0, mod x is equal to only x minus 1. Now simplify. This is a minus 1 here. Left hand limit on simplification a minus 1. Right hand limit also leads to same value here. Limit x tends to a plus fx. If you take, this is limit x tends to a plus fx value is equal to definitely mod x minus 1, no change, because it is on right side of 0. Right side of 0, the function is defined by mod x minus 1. When it is right side of 0, mod x is also defined as simply x minus 1. So the answer is a minus 1. So right hand limit on simplification leads to a minus 1. Left hand limit is also leading to a minus 1. Therefore, what we conclude, LHL is equal to RHL and both are tallying with a minus 1. So it means limit x tends to a fx exists when a is greater than 1. When a is greater than 0, sorry. A is greater than 0. Condition when a is greater than 0, limit exists here. Now, ಎರಡು ಕೇಸ್ಗೆ ಕನ್ಫರ್ಮ್ ಮಾಡಿದೆ ಏನು, a less than 0 as well as a greater than 0. ಇಲ್ಲಿ ನಾವು ಹೇಳಿದ್ವಿ ಲಿಮಿಟ್ ಎಕ್ಸ್ ಟೆನ್ಸ್ ಟು a fx ಎಕ್ಸಿಸ್ಟ್ ಆಗಿದೆ ಫಾರ್ ಆಲ್ a ನಾಟ್ ಈಕ್ವಲ್ ಟು 0. a ಈಕ್ವಲ್ ಟು 0 ಇದ್ದಾಗ ಮಾತ್ರ ವ್ಯಾಲಿಡ್ ಇಲ್ಲ, ಡಿಫೈನ್ ಆಗ್ತಾ ಇಲ್ಲ, ಲಿಮಿಟ್ ಎಕ್ಸಿಸ್ಟ್ ಇಲ್ಲ. ನಾಟ್ ಈಕ್ವಲ್ ಟು 0 ಅಂದ್ರೆ ಇದ್ರ ಅರ್ಥ ಏನು, ಲೆಸ್ ದೆನ್ 0 greater than 0. When a is less than 0, I have proved left hand limit is equal to right hand limit. When a is greater than 0, then also I have proved that left hand limit is equal to right hand limit and its value is found to be a minus 1. So it confirms that limit x tends to a fx exists for all a not equal to 0. So this is what the conclusion as far as this problem is concerned here. Now let me continue the next example. See, one more interesting and simple example. Consider the given condition, limit x tends to 1, fx minus 2 divided by x square minus 1. X square minus 1 equal to pi. Now this limit can be applied to both numerator as well as denominator. So you do like this, limit x tends to 1, fx minus 2 you write here. Rules of limits I would like to apply. Take limit to the denominator here. So limit x tends to 1, x square minus 1. Just like usual simplification, you cross multiply limit x tends to 1, x square minus 1 to right side here. So as a result, this becomes limit x tends to 1, fx minus 2 is equal to pi into limit x tends to 1, x square minus 1 here, x square minus 1. Now left hand limit, you just apply the limit x tends to 1, limit x tends to 1 fx. I would like to split here, minus limit x tends to 1, 2. This is equal to, see how it is, fx is there, minus 2 is there. Limit x tends to a f of x minus g of x is equal to limit x tends to a fx minus limit x tends to a g of x. That is the rules of limits I am applying. And then pi is there outside, limit x tends to 1, x square minus 1 is there here. Please concentrate here. You substitute x equal to 1 at this stage here. Directly it can be evaluated here. So this is equal to pi as it is outside 1 square minus 1. X square minus 1 is there, no it is x square minus 1. Yes, x square minus 1 Let us substitute this value. So this is equal to limit x tends to 1 fx as it is, and its answer is 2 because it is constant here. Constant. Limit x tends to a k equal to only k. You know already. Right side it becomes 0. So limit x tends to 1 fx is equal to what you are getting? 2 you are getting. Minus 2 is shifted to that side. So it becomes plus 2. So this is what the answer. Nothing to calculate. We need to find out what? See the question. What we need to find out? Limit x tends to 1 fx we need to find out. That we have calculated. ಇಷ್ಟೇ ಅಲ್ಲ. ಲಿಮಿಟ್ ಎಕ್ಸ್ ಟೆನ್ಸ್ ಟು 1 fx ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕಾಗಿದೆ, ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡಿದ್ವಿ. ಸೊ ಏನಾದರೂ ಡೌಟ್ಸ್ ಇದ್ದರೆ, ಈ ಪ್ರಾಬ್ಲಮ್ ಏನು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಆಗಿರಲಿಲ್ಲ ಅಂದ್ರೆ ಹೇಳಿ, ಯಾವುದೇ ಸ್ಟೆಪ್ ಅರ್ಥ ಆಗಿಲ್ಲ ಅಂದ್ರೆ ಮತ್ತೊಮ್ಮೆ ಹೇಳ್ತೀನಿ. ಓಕೆ, ಇಸ್ ಇಟ್ ಕ್ಲಿಯರ್ ದಟ್ ಪ್ರಾಬ್ಲಮ್? ಅರ್ಥ ಆಗಿದೆಯೋ ಇಲ್ಲೋ?
Yes, sir.
Then let me continue the next example and the last example in this exercise. ಹೆಚ್ಚು ಕಡಿಮೆ ಲಿಮಿಟ್ಸ್ನಲ್ಲಿ ಲಾಸ್ಟ್ ಎಕ್ಸಾಂಪಲ್ ನಿಮ್ಮ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಮುಖೇನ ಪ್ರಕಾರ mx square plus n first one, next nx plus m when 0 is less than or equal to x is less than or equal to 1, nx cube plus m. Okay, when x is greater than 1. For what integers m and n does both limit x tends to 0 fx and limit x tends to 1 fx exists? ಸೊ ಫಂಕ್ಷನ್ ಯಾವ ರೀತಿ ಡಿಫೈನ್ ಆಗಿದೆ ಅನ್ನೋದನ್ನು ಸ್ವಲ್ಪ ಗಮನ ಕೊಡ್ಲಿ. 3 ರೀತಿ ಇದೆ, ಇದು ನಿಮಗೆ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಗಬೇಕು. ದಿಸ್ ಈಸ್ ವಾಟ್ ದ ಸಿಚುವೇಶನ್ ಹಿಯರ್. ಲೆಟ್ ಅಸ್ ಟ್ರೈ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್. ದ ಫಂಕ್ಷನ್ ಈಸ್ ಡಿಫೈನ್ಡ್ ಇನ್ ದಿಸ್ ಮ್ಯಾನರ್. ಟೇಕ್ 0 ಪಾಯಿಂಟ್ ಹಿಯರ್, 1 you take here, 0 1. This is less than 0, x less than 0. This is x greater than 0. ಈ ಕಡೆ ಎಲ್ಲ ಎಕ್ಸ್ ಗ್ರೇಟರ್ 0, ಆ ಕಡೆ ಈ ಕಡೆ ಎಲ್ಲ 0 to 1. ಇದು ಎಕ್ಸ್ ಗ್ರೇಟರ್ ದೆನ್ 1 ಆಗುತ್ತೆ. ಎಕ್ಸ್ ಗ್ರೇಟರ್ ದೆನ್ 1. ಎಸ್, 1 ಆ ಕಡೆ ಎಕ್ಸ್ ಗ್ರೇಟರ್ ದೆನ್ 1 ಆಗುತ್ತೆ. ಇಲ್ಲಿ ಫಂಕ್ಷನ್ ಯಾವ ರೀತಿ ಡಿಫೈನ್ ಮಾಡ್ತಾನೆ? ಸಿ ಎಕ್ಸ್ ಲೆಸ್ ದೆನ್ 0 ಫಂಕ್ಷನ್ ಈಸ್ ಡಿಫೈನ್ಡ್ ಬೈ ಎಮ್ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ ಎನ್. ಇನ್ ಬಿಟ್ವೀನ್ 0 and 1 it is defined as nx plus m. fx is equal to nx plus m. fx is equal to nx plus m you can write. Okay, and then further when x is greater than 1, nx cube plus m. fx is equal to, this is nx cube plus m, nx cube plus m. Okay, so this is what the given function. Just function ಯಾವ ರೀತಿ ಇದೆ ಅನ್ನೋದನ್ನ ಹೈಲೈಟ್ ಮಾಡಿದ್ದೇನೆ ಇಲ್ಲಿ ಇಷ್ಟೇ ನಂಬರ್ ಲೈನ್ ಮೇಲೆ. For what integers m and n, for what integers m and n, ಇಲ್ಲಿ ಫಂಕ್ಷನ್ನಲ್ಲಿ m ಮತ್ತು n ಇದೆ, ಆ ಬೆಲೆ ಏನಿದ್ದಾಗ ಲಿಮಿಟ್ ಎಕ್ಸ್ ಟೆನ್ಸ್ ಟು 0 fx and limit x tends to 1 fx exists. ಒಂದೊಂದಾಗಿ ಚೆಕ್ ಮಾಡೋಣ. x tends to 0 ಅಂದರೆ in the neighborhood of 0 we need to check the left hand limit and right hand limit. See, limit for limit x tends to 0 fx to exists, what is your basic condition? Left hand limit, that is limit x tends to 0 minus fx must be equal to limit x tends to 0 plus fx. These two must equate. ಇದನ್ನು ಇಕ್ವೇಟ್ ಮಾಡ್ಕೊಳ್ಳೇಬೇಕು ನಾವು. ಇದು ಎಕ್ಸಿಸ್ಟ್ ಆಗಿರಬೇಕು ಅಂದರೆ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಲಿಮಿಟ್ ಮಸ್ಟ್ ಬಿ ಈಕ್ವಲ್ ಟು ವಾಟ್ ಹಿಯರ್? ರೈಟ್ ಹ್ಯಾಂಡ್ ಲಿಮಿಟ್. ಲಿಮಿಟ್ ಎಕ್ಸ್ ಟೆನ್ಸ್ ಟು 0 minus fx. ಲಿಮಿಟ್ ಎಕ್ಸ್ ಟೆನ್ಸ್ ಟು 0 minus fx means what? fx ಏನು ಹಾಕೋಬೇಕು ಇಲ್ಲಿ? ಡೈರೆಕ್ಟ್ ತುಂಬ್ಕೋಬೇಕಲ್ಲ. ಸಿ fx what I would like to take here, fx equal to x tends to 0 minus means x is less than 0. Please concentrate here. It means x is less than 0. When x is less than 0, at that time the function is defined by fx equal to mx square plus n. This is equal to mx square plus n you should write. And then limit x tends to 0 plus means when x is greater than 0. X tends to 0 plus means x is greater than 0. When x is greater than 0, the function is defined by, see this is 0, here it is 0 here. Greater than 0 means you might be confused whether we need to take nx plus m or nx cube plus m. ಎರಡು ಕಾಣಿಸ್ತಾವೆ ಇಲ್ಲಿ ಫಂಕ್ಷನ್ ಗ್ರೇಟರ್ ದೆನ್ 0 ಒಳಗನ. ಬಟ್ tending limit greater than 0 means it is not far away, very close to 0, that is 0.001, 0.00001 something. It means definitely in this range 0 to 1. Fx is defined as nx plus m. So you need to take nx plus m, you need to take. ಇದನ್ನೇ ಯಾಕೆ ತಗೊಂಡ್ವಿ, ಯಾಕೆ ತಗೊಂಡ್ಬೇಕು ಅಂತ ಅರ್ಥ ಆಗ್ಬೇಕು ನಿಮಗೆ. x tends to 0 means x tends to 0 plus means x is greater than 0. x is greater than 0 ಅಂತಂದ್ರೆ ಇಲ್ಲಿ ಬಹಳ ದೂರ ಹೋಗಂಗಿಲ್ಲ, ಅದರ ನೇಬರ್ಹುಡ್ ಒಳಗೆ ಅದರ ಸಮೀಪನ ಹೋಗಬೇಕು. ಸಮೀಪನ ಅಂತಂದ್ರೆ ಏನು, ಇನ್ ಬಿಟ್ವೀನ್ 0 and 1 ಯಾವ ಫಂಕ್ಷನ್ ಡಿಫೈನ್ ಆಗಿದೆ, fx nx plus m ಅಂತ ಡಿಫೈನ್ ಆಗಿದೆ, ಅದನ್ನೇ ತಗೋಬೇಕು. ಸೊ ಈ ಸೆನ್ಸು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಯ್ತು ಅಂತ ಭಾವಿಸ್ತೀನಿ. ಲೆಟ್ ಅಸ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ x equal to 0 here. So it is 0 plus n and then this is 0 plus m. So n equal to m. Okay, this is what the condition is. N is equal to m. So what we conclude, first case, limit x tends to 0 fx to exists we need. So for limit x tends to 0 fx to exist, the condition is n must be equal to m. The value of n and m must be equal to same. ಈ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಒಳಗಡೆ, ಫಂಕ್ಷನ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಒಳಗಡೆ n ವ್ಯಾಲ್ಯೂ ಮತ್ತು m ವ್ಯಾಲ್ಯೂ ಎರಡು ಸೇಮ್ ಆಗಿ ನೀವು ಯಾವುದೇ ಫಂಕ್ಷನ್ ತಗೊಳ್ರಿ ಇದು ಡಿಫೈನ್ ಆಗತ್ತಾ, ಎಕ್ಸಿಸ್ಟ್ ಆಗಿರ್ತದೆ ಅಂತಕ್ಕಂಥದ್ದು ಕಂಡು ಬರ್ತದೆ. ಇನ್ನು ಎರಡನೇ ಪ್ರಾಬ್ಲಮ್ ಏನು, ಲಿಮಿಟ್ ಎಕ್ಸ್ ಟೆನ್ಸ್ ಟು 1 fx ಎಕ್ಸಿಸ್ಟ್ ಆಗಿರ್ಬೇಕಂತೆ. ನೆಕ್ಸ್ಟ್ ಫಾರ್ ಲಿಮಿಟ್ x tends to 1 fx to exist, the condition is basic condition is what's the condition, can you tell me? ಲಿಮಿಟ್ x tends to 1 fx ಎಕ್ಸಿಸ್ಟ್ ಆಗಿರಬೇಕು ಅಂದರೆ ಕಂಡೀಷನ್ ಏನಾಗಿರಬೇಕು, ಯಾರಾದ್ರೂ ಹೇಳ್ತೀರಿ? ಏನಾಗಿರ್ಬೇಕು ಕಂಡೀಷನ್? ಲಿಮಿಟ್ x tends to 1 fx ಎಕ್ಸಿಸ್ಟ್ ಆಗಿರ್ಬೇಕಂದ್ರೆ ಸಾಧ್ಯ ಇಲ್ಲ ಹೇಳಲಿಕ್ಕೆ. ನೋಡ್ರಿ, fx ಲಿಮಿಟ್ ಆಫ್ fx ಆಸ್ x tends to 1 ಎಕ್ಸಿಸ್ಟ್ ಆಗಿರಬೇಕು ಅಂದರೆ ಇದನ್ನ ಬಿಡೋಣ. ನಿಮ್ಮ ಬೇಸಿಕ್ ಡೆಫಿನೇಷನ್ ಏನದ ಲಿಮಿಟ್ಸ್ದು? ಲಿಮಿಟ್ ಎಕ್ಸ್ ಟೆನ್ಸ್ ಟು ಎ fx ಎಕ್ಸಿಸ್ಟ್ ಇದೆ ಅಂತಂದ್ರೆ ಇದರ ಅರ್ಥ ಏನು? ವಾಟ್ ಡಸ್ ಇಟ್ ಮೀನ್? ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಲಿಮಿಟ್ ಮಸ್ಟ್ ಬಿ ಈಕ್ವಲ್ ಟು ವಾಟ್ ಹಿಯರ್? ರೈಟ್ ಹ್ಯಾಂಡ್ ಲಿಮಿಟ್. ಇದು ಸಾಧ್ಯ ಐತೋ ಇಲ್ಲೋ? ಇಷ್ಟೇ ಹೇಳ್ಬೇಕಲ್ಲ ಇಲ್ಲಿ. ಲಿಮಿಟ್ ಎಕ್ಸ್ ಟೆನ್ಸ್ ಟು 1 fx ಎಕ್ಸಿಸ್ಟ್ ಆಗಿರಬೇಕು ಅಂತಂದ್ರೆ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಲಿಮಿಟ್ ಆಸ್ ಎಕ್ಸ್ ಟೆನ್ಸ್ ಟು 1 and right hand limit as x tends to 1 must be same here. X tends to 1 minus fx must be equal to limit x tends to 1 plus fx. So 1 minus fx ಅಂದ್ರೆ x less than 1. x less than 1 ಇದ್ದಾಗ ಏನು ಫಂಕ್ಷನ್ ತಗೋಬೇಕು ಅಂತ ಗಮನಿಸಬೇಕು ಇಲ್ಲಿ. x less than 1 ಇದು 1 ಪಾಯಿಂಟ್ ಇದೆ, 1 ಲೆಫ್ಟ್ ಬರಬೇಕು, nx plus m ಆಗುತ್ತಾ. ಸೊ ದಿಸ್ ಈಸ್ ಈಕ್ವಲ್ ಟು ಲಿಮಿಟ್ x tends to 1 minus means less than 1, fx is defined by nx plus m and this is equal to limit x tends to 1 plus. ಗ್ರೇಟರ್ ದೆನ್ 1 ಇದ್ದಾಗ ಫಂಕ್ಷನ್ ಯಾವ ರೀತಿ ಡಿಫೈನ್ ಆಗಿದೆ ನೋಡ್ರಿ. ಗ್ರೇಟರ್ ದೆನ್ 1 ಗೆ nx ಕ್ಯೂಬ್ ಪ್ಲಸ್ m ಇದೆ. ಸೊ ದಿಸ್ ಈಸ್ nx ಕ್ಯೂಬ್ ಪ್ಲಸ್ m, ದಿಸ್ ಈಸ್ nx ಕ್ಯೂಬ್ ಪ್ಲಸ್ m. ಸೊ x tends to 1 minus, that is n into 1 only for calculation purpose. This is m and this is n plus m. X value is 1 here. 1 cube is 1 only. Okay. So n plus m must be equal to n plus m. See, both have same here. So what we conclude, for all values of m and n, limit x tends to 1 exists. Okay, for all values of m and n. ಇಲ್ಲಿ m n ಏನೇ ತಗೊಳ್ಳು ಅವೆರಡು ಇದ್ರ ಸಮ ಅದ್ರ ಸಮ ಎರಡು ಸೇಮ್ ಆಗ್ಬಿಡ್ತಾವ. ಸೊ ಫಾರ್ ಆಲ್ ವ್ಯಾಲ್ಯೂಸ್ ಆಫ್ m and n ಲಿಮಿಟ್ x tends to 1 fx exists ಅಂತಕ್ಕಂಥದ್ದು ನಮ್ಗೆ ಕಂಡು ಬರ್ತದೆ. ಮತ್ತು ಆ ವ್ಯಾಲ್ಯೂ ಏನಾಗಿರಬೇಕು, ಆ್ಯಂಡ್ ದಟ್ ಲಿಮಿಟ್ x tends to 1 fx value both left hand limit and right hand limits must be same here, n plus m and n plus m. So this must be equal to n plus m. So ಇಷ್ಟು ಆಗಿರಲಿಕ್ಕೆ ಸಾಧ್ಯ ಇರುತ್ತೆ ಅಂತಕ್ಕಂಥದ್ದನ್ನು ನಾವು ಗಮನಿಸ್ತೀವಿ. So this completes the solution for the last example in your exercise, and we will continue a very, very important another concept in the same topic, that is what derivatives, in the next class.